Okay, we're moving into climate and climate change. Uh, you could spend a year talking about this, so you're only going to get some of the highlights, which is probably a good thing. Uh, Climate is extremely complex, and that means climate change is very complex. So we're going to explore a little bit of it here. And for your information, this chapter was totally redone this year. There is so much new information in it. So be careful when reading through it. So what we're going to basically explore is how and why does climate change? Uh, it talks about an environmental sustainability study done in Houston, Texas. I've been involved in some of these here in Norfolk area, and really it's trying to look at options. The whole thing is to develop a toolkit that if certain things begin to happen, then these actions can be taken by that city to help protect their population and make them less vulnerable to changes that occur. Uh, for example, in New York City, if sea level rises so many feet in the next 20 years, they have some steps in place that they plan on implementing that would mitigate that to some extent and not cause as much damage in the downtown area. Man, in Manhattan, for example. In Norfolk area, for example, they are looking at how, with the sea level rise, if it continues, what that means for places like Sandbridge, which is an island on literally by the ocean, or there are other places as well that have been. These literally are islands that were developed from hurricanes. So these are all options. We talked about it when we had the hurricane chapter that a lot of potential damage comes from hurricanes and they on these barrier islands. Well, Norfolk has several barrier islands around it, and there's actually industry on some of those islands. The Navy base is right next to one, for example, the world's largest Navy base. Uh, if you go up the river a little bit, right along it, is a several huge shipyards. There is a huge ship transportation system out there. All of these will be impacted if the water continues to rise. As a matter of fact, they did a study in Norfolk, just like they did in Houston, Texas, and said, okay, let's take a 2 foot sea level rise over the next 50 years. That may or may not occur. We know, for example, that since 1930 to now, we've had 8 inches of sea level rise. So if it continues to accelerate at that rate, maybe we will have 2 feet, maybe we won't. What did that impact? And there were literally 10,000 houses that would be impacted by that. That's 10,000 people that would have to relocate, or we would have to build structures to take care of them, to prevent the water from getting into their homes, literally dikes almost to that extent. So all these are things that are based on climate change. So climate, let's go back a slide here, is a whole complex system. It's not just the atmosphere. It has the hydrosphere, which is water and ice, the lithosphere and the biosphere are all things that interact to make climate. So it's a system of complex things working together to create the climate. Weather is just inside that. Weather systems that occur within the subset of possible outcomes within a climate. There are certain limiting factors. In other words, we're not going to get a hurricane that has 500-mile-an-hour winds with the current climate we have, or we're not going to get 5,000 tornadoes in 1 week with the current climate we have. All of these could change if climate change. If you change the parameters of climate, you change what may occur in the weather. So we can see here the graphs all show rising weather. And yes, currently we are seeing less glaciers. As a matter of fact, I made a trip to Alaska a few years ago and saw a huge change from where a glacier had been 20 years earlier to where it was now. And all these could be natural. We can't be 100% sure. But we also don't know if they aren't. And guess what? Most of this global warming is actually going into the oceans. If you go in and look at the sea level temperatures, and throughout the whole ocean, look at the depths of the ocean. And they've done some studies of this. The depths of the ocean are warming more than they've ever known them to warm. Now, they look at sea level things with this, and you can see changes in habitats. For example, we have never had an alligator here in southeastern Virginia. However, last year they found an alligator in the swamp down to my south. And it was the first time in history that there ever was one there that they could ever record back into the 1600s. So that's something to think about. So, climate normals. We look at normal temperatures, and they're inside the climate system as we know it. And we do a 30-year average of temperatures, pressures, precipitation. If you go to any National Weather Service site, you can see your climate, what the normal temperature is. But there's always a distribution of temperature. Most temperature should fall right in this realm here. The extremes should be in very outside edges. So, but what has been happening is this curve, instead of being nice and even like this, has been shifting to the right more and more. And this is getting lower, and this is getting further and further over. The same could be happening with extremes of precipitation. We're getting higher and higher precipitation totals. So another thing to look at is variability of climate, trying to figure out whether this is all variable or not. One of the interesting things about climate and professional papers of it, when I worked for NOAA, if I wanted to get a paper published, I had to have it peer reviewed. What does that mean? I had to have at least 2 to 3 other scientists review my paper in order to ascertain if it met professional standards, if it was scientifically valid. So in order to publish that paper, I had to have that peer review process. And peer review processes are the way to determine if something is reliable or not in a scientific paper. If you can get 4 scientists, all fairly respected scientists, to agree that that paper is worth publication, the odds are that it's fairly credible. If you only have just a paper published with no peer review, it gets a little bit more iffy. So climatology, again, has been changing, especially since the 1980s. And the idea is to use the scientific method to determine. So they propose a hypothesis, they come up with an explanation for why it might be happening, and then try to prove that hypothesis. And if they don't come up with any verification, they start again. And again, weather and climate are not equal. They are very different. So, for example, global radiation equilibrium. Think about it. All this energy comes in from the sun. That energy probably isn't changing a whole lot. But how much leaves the Earth? That could be altered by greenhouse gases or some other mechanism such as volcanoes. And so that impacts then how much energy and how much temperature and how the atmosphere. It's a natural driver of climate change. So we can look, for example, at when solar radiation changes. And it happens to change based on sunspot activity, they found. When excessive sunspots, you get more of them, you get a different change to the temperatures. And that corresponded somewhat with a cold episode in Maunder minimum and Spora minimum, and another one. All indicated little ice ages or colder temperatures. Technically, we're in one of those minimums. We have been for a little while now. Sunspots are just now beginning to increase. Other changes, long-term changes over global orbits. For example, when a perihelion, for example, right now, the Earth is actually closest in January to the sun. What happens when that flips in 11,000 years? Maybe that changes how climate reacts. Of course, I don't think I'll be around 11,000 years. The Earth tilt changes. For example, we know it's varied from 21 to 22 degrees to 24 and a half. Right now it's 23 and a half. But it does this over a time frames of tens of thousands of years. So it's not something that's going to contribute very frequently to climate. This is just an example of showing how the ice sheets changed over time. They've looked at the sediment in the ocean, for example, and you figure 1 to 3 millimeters per century. So they tried to do an analysis way back in time to see what changed. And there were some changes in climate, and were able to observe some of these cycles that we theorize might be there. Plate tectonics. There's actually a forecast in plate tectonics that says there'll be a mountain range form in the next 10,000 years in Florida. That would change tremendously the climate in Florida and in a lot of the United States if it actually occurred. Volcanoes. Volcanoes can put up tremendous amounts of gases and dust, and they change temperatures. When Pinatubo erupted in 1992, and I remembered this because it was one of the coolest summers you could ever have remembered. But look at this, 5 to 6 degrees colder than normal. And there actually were days it almost snowed in some of your Great Lakes counties up there. So these are all natural feedbacks that occur. Another feedback that occurs is ice melting. Think about it. If you have no reflection, your ice is getting not there. What's going to happen? Well, the sun's going to get absorbed more by the oceans. And what happens? You wind up getting more and more heating of the oceans, which melts more and more ice, which causes unfortunately, feedback the wrong direction, maybe. However, if you get a new freshly fallen snow, you get a really cold winter, maybe up in the Arctics, and it lasts a long time. You get a whole tremendous snowpack. You're going to get a lot lower temperatures, a lot less radiation is going to be available to use for warming of it. And right now, unfortunately, there is some times in the Arctic where you can actually move through and actually have ships pass through the Arctic, which we couldn't do 20 years ago. So there are numerical models to look at this, or physical models. One of them is Kowat's modeling system. It really takes into effect all kinds of things to try to forecast what the future holds, and looks at study, particularly in coastal climates. Global climate models, the U.S. has 2 of them that I'm aware of. Europe has several. I believe Russia has some, and China as well. You can see here the modeling that's all gridded, and it takes into account, it parameterizes the physical processes. As I've stated all along, we cannot look at exactly solve the mathematical equations. And because it's not trying to forecast the weather, it's looking at broader terms. For example, I have seen studies where they run these over the course of 100 years and look at how hurricanes, they try to identify hurricanes in them, and just see how they change year by year and see what the trends would be and the intensities might be. Maybe they'll look at how many cold fronts would pass a certain location over a given amount of years to try to get a trend on how the models and how climate is changing. All of these are part of the feedback you get from climate. And they have tried to go back and look in time to see how they've reflected in their skill. And that is one of the things that they've gotten better at, but there's still a lot of questions out there. It's still a model, and it's always got to be remembered that it is a model. So they look at the feedback and how different feedbacks might impact climate. They're looking at greenhouse gases over time, of course, and N2O, lifetime of 110 years. Even if we cut the emissions by 50%, we would stabilize it, but it would still be around and not change over that lifetime. Methane degrades very slow. CO2 is very complicated. A lot of CO2 winds up in water. So what happens if we keep heating water, our oceans? Does that CO2 get released? There's some new studies that say yes, more of that CO2 will actually go back into the atmosphere and not be in the ocean as long. But you can see timescales are very, very long term with these gases. Now, I've talked a lot about climate variability and vulnerability. Just look at all the cities along the world that could impact it if sea levels were to rise significantly. Or if storms can, if say a sea level rise is a foot, all of a sudden you get a hurricane in there. What happens? Well, places that wouldn't have got impacted now are getting impacted because 1 foot in sea level is huge compared to what can happen at the coast and United States. And I happen to live in an area that's fairly vulnerable down here. We've had significantly rising sea level, and the East Coast, Florida in particular. Uh, we found it when we had Isabel go through. Isabel had almost exactly the same storm surge as a 1934 hurricane, yet we could go back and compare places that got hit by that previous hurricane and find it 8 inches difference. And that is exactly what sea level has risen between Isabel's time and that time. So ice sheets melting. Antarctica has 2 large ice sheets, which would have monstrous impacts on global climate if they were to melt. We talk about rivers of ice that they're trying to understand now and how they move. And ice moves at a certain speed and maybe changes. And some of the sheets are over land, but what happens if they begin to pull away? The bottom starts melting. So they're not over land anymore and actually have water under them. All of this could change. Greenland has been melting for the last several years, and we can see really a shrinkage in the amount of ice over Greenland at times. Again, what happens with that means that you've got less ice, you have less reflectivity of that, so you're going to heat up the ground more, so you actually have a feedback mechanism. So this is really what I wanted to talk about here. There's a lot of stuff here. If you have any questions, please don't hesitate to ask.